So we are going to start with something that was from some of the weekend's homework, which will be part of your quiz on Wednesday. What's your quiz on Wednesday about? Wednesday quiz. Measuring. Wednesday's quiz is on measuring. Tuesday's quiz, counting sig figs. This pen does not work. Okay. 1.4. So we are going to turn to page 83. 83. Oh my gosh, what was it? What page was it? 83. There we go, 83. Okay. Eight three. Yeah. I'll get that number up there too so you can see it. So first of all, this measuring device is called a burette. B-U-R-E-T-T-E, or if you prefer, you can spell it burette. Doesn't matter. Okay? This particular measuring device, it's not used to contain a liquid. That's not its purpose. What it is used for is you start with a particular volume. So let's say that we filled our burette up, and just to be clear, the number, the top is 0 and the bottom is 50. So you start at 0 and you go down to 50. And I know that might sound a little bit weird, but that's how it works, and we'll explain why that is. So if I were to fill this burette up with some, actually, let's make it green, just like in the picture. Last time I did yellow and it looked like we were filling the burette with pee, and maybe that's not really appropriate. So let's say that we filled up our burette with this green liquid to right here, okay? So that is our initial volume. Do you guys know what the word initial means? Initial means starting. So you will always have an initial volume, which means your starting volume. And because it is initial, we can give it the symbol I. So all you need to do is call it VI, okay? Your final volume, I think that speaks for itself, that is your ending volume, is VF. So when you were recording your measurement, do you remember how we always had to do length of pencil equals? Yeah? In this case, you won't be writing length of pencil because you're not measuring length nor a pencil. You'll say my initial volume is, and then you'll record your number. Yes? And the unit. Anytime you are using a burette, you're never going to make one measurement. You're always going to make 2 measurements, starting and finishing. Initial and final. So let's just look at this for a moment. Let's not worry about sig figs just for the moment. And let's look at our starting volume. Oh, by the way, do you know what we call this scoop? Water tends to make a little scoop when it's in a container. Anyone know what that's called? Starts with an M. May have learned it in home ec.
In what?
In home ec. The meniscus? Have we never heard of the meniscus? Yeah, you have heard of it. Okay, good. Some of you have. Excellent. That scoop is called the meniscus, and we always measure at the bottom of the meniscus. And I'm going to get lazy. I'm just going to point to that word there. So always measure at the bottom of the meniscus. And we have to remember that this is measuring from 0. We start at 0 and we go down to 50. So my number 1, my 2 is here. My 3 is here. 3 milliliters, 2 milliliters. My 1 milliliter would be up here someplace. Yes? So I am starting at approximately 2 milliliters. Like I said, we're not going to worry about sig figs right this second. And we are finishing at approximately what? 8 milliliters. How would we find out how much was dripped out? We started at 2. We opened this little valve here and the liquid dripped out. We started at 2. We finished at 8. How much came out? 6. Easy? Yeah. Okay? Nothing magical to it. You just have to remember that this goes downward. Okay? People get in front of this and they want to start, instead of writing 2 milliliters, they'll be like 50 minus 2 is 48. And I don't really know why. But anyway, don't do any of that. Just read the number off of the thing. Yes? Okay. So now let us take our volume here. And we know that this is a 2 right here. What's this one here? This is 2 point what? 2.1, 2.2. Okay. And this one right here would be 1.9. So if we wanted to record this to correct sig figs, what would our measurement be at the bottom of the meniscus? We're measuring the initial volume at the volume of the meniscus at the bottom of the meniscus, and we're doing it to correct sig figs.
I say 2.0 plus minus 1.
You can say, now this right here is 2.0.
Yeah, can I just say 2.0 plus minus 0.1?
No, you're close.
2.1?
No, because 2.1 is here.
Yeah, because the
Are we thinking maybe the bottom of the meniscus is here?
Oh. Where is that 2 though?
Are we, oh, I was not doing sig figs.
Oh.
Okay, this was just to get you the idea of 2 and 8. Okay. But we're doing sig figs now. Now we're doing sig figs. Okay? What is this distance here? How much?
0.1.
0.1. So we can estimate to 0.01. Okay? Now, let's say that I thought this was just above the 2. So it's in between 1.9 and 2. I might say that that is 1.99. Does that make sense? Right? Because we're somewhere between 1.9 and 2.0, 1.99. Okay? So we could say that our initial volume is 1.99. Or, and you were so close, Mahan, we can't say 2.0 because we're not unsure about that 0. I know it's a 0. I am not wondering if that is a 2.1. I am not unsure.
So we say 2.0 plus minus 0.001. Yeah,
Like that?
I think you missed some, yeah, like that, yeah.
You're so close. If this is my uncertain digit,
Yeah.
then this is my uncertain digit. So it has to be
it's
2.0.
0.01.
Oh, yeah. So it has to be 2.00. Okay, so your other option would be 2.00. Is good? Because it measures the smallest division is 0.1, so we can estimate to 0.01. All right, what am I missing in my measurement?
Units.
Units, milliliters, milliliters. Okay. How many sig figs in each of these measurements? 3 sig figs. And let's now record our final volume. Tell your partner, what should that final volume be recorded as? 7.99, or
8.8.
you could say 8.00, something like that, okay? As long as you're within 0.1 or so, you're good to go. What have I forgotten here? Units. What else have I forgotten? What I am measuring. In this case, I am just measuring the final volume. So I'm going to say VF equals. Now, if you are asked to do a calculation with this, you are going to have to do 3 things. And the first thing you're going to have to do is to write the formula. Okay, so don't put numbers in right away. You need to write the formula. And here we are calculating the volume delivered. What did we use to calculate the delivered volume? We used our initial volume, yes, and we used our final volume. And which one went first and which one got subtracted? Final minus initial. VF minus VI. So you get 1 mark for that.
I do?
Yeah.
Wait, look at the extra one now.
So anytime you are writing a formula, you get a mark. Whoa, look at that. Okay? Just like when you're recording it, you get a mark for saying VF, you get a mark for saying the correct number, you get a mark for having the correct number of digits, and a mark for the units. Okay? So 4 marks, or maybe 2 marks if I do half marks. Okay? Then you get marks for plugging in the values with the units. So that would be, let's just do the easy one, 8.00 milliliters minus, sorry, that doesn't look like a minus, minus 2.00 milliliters. Or if you prefer, actually I shouldn't put that in brackets because that's just going to get complicated. Or you could do, in brackets, 8.00 minus 2.00 bracket milliliter. That way the milliliter applies to both things inside the brackets. Either way is fine, but both numbers need milliliters. You can either write it for both or put them outside the bracket. And then you would get 6.00 milliliters. So you would get a mark for this, you would get a mark for the numbers, and then mark for the units, and then you'd get number and units, so it's worth a whole lot. Okay? All right. Write the formula, plug in the values, calculate the final answer, and do it with units. You have to do this all the time in chemistry. Is good? Okay. One of your homework problems today, page 86, number 17, is going to be using this method, so make sure you do it. We're not going to do it right now. Right now, we are going to do some exponents. Okay? So if you feel like you are a scientific notation and sig fig expert, you could work on page 86, number 17, but you need to make sure you understand sig figs with scientific notation. So let's go do that. And that is somewhere over there. There we are. Page 110, actually 109, page 109. Right at the very bottom. Probably Monday, because I think we're doing vocab on Friday. Yeah. Did I actually answer your question, or did I just make up what you said in my head? Sometimes I do that. Sometimes I'm like, I can kind of hear you, and I'm like, okay, I'll just kind of answer what I think you said. Did I answer your question? We didn't finish it. No, yeah. So okay. I didn't answer your question at all. I have no idea. Okay. So on page 109, we got to here. And just to remind us how scientific notation works, you need to have one non-zero digit in front of the decimal. And if your number does not have a decimal, you can draw one in at the end and say, I now need to move it so there's only one digit in front of the decimal. So I'm going to move this, and I'm going to count by threes because that makes my life easier. 3, 6, 9. 3, 6, 9. So this number becomes 9.3. Should I put some zeros after that 3? No, because this has how many sig figs? Really? If there is, I drew a decimal here. Whoops, that was supposed to have been erasing. I drew a decimal better, but there really isn't one. And if there's no decimal, how many sig figs in this number? 2. So I only want 2 sig figs here. Okay, and so that would be 9.3 times 10 to the 369. And because this is a big number, and remember, what does big mean? It means bigger than how much? Bigger than 1. Yeah, so then it will be a positive exponent. So 9.3 times 10 to the 9.
So before the decimal, it can't be 0. Right?
Cannot be 0 before the decimal. Not, no, it can't ever. Can't ever. Okay? Now, what if I did something like this? What if I threw in an overbar? Oh, God help us. What if I threw in an overbar here?
Okay.
What would change? How many sig figs would we have now?
4.
We would have 4. 1, 2, 3, 4. So that means that I would need to have now 9.30
0.
because I have 4 sig figs times 10 to the 9. Okay? So those are positive exponents. Let's try some negative exponents. Or actually, before negative, we've got some special cases. 4.6. Is that in scientific notation? This is on page 110. No, because we need something, we need it to be times 10 to the something. I'd like you to tell your partner what that number should be. Up in the box. What should that number be, the yellow one? So we have a choice. If we say 4.6 times 10 to the 1, hold on, hang on. If I say 4.6 times 10 to the 1, 10 to the 1 is just 10. So that would equal 46, and I don't want to have 46. So it's going to be 4.6 times 10 to the 0, because remember, any number to the power of 0 is equal to 1. Yes? So this would equal 4.6 times 1, which is equal to 4.6, which is what we wanted. Is good? Okay. Special case number 2, and I bring this up because people get messed up by it, because like the whole 10 to the 0 and the 10 to the 1 seems to freak people out. We have 83.4. This becomes 8.34 times 10 to the what? We moved our decimal place 1 place, so that's just going to be times 10 to the 1, which shouldn't be complicated, but sometimes it just messes with people's heads. Okay? Now, working with small numbers. Here's a small number because it is less than 1. We're going to move our decimal again. 2, 3, 4 places. So it's got 1 non-zero digit in front of the decimal. 1, 2, 3, 4. And so that becomes 7.6 times 10 to the, we've moved our decimal place 4 places, but it is a small number. And when it's a small number, what kind of exponent? Negative exponent. So that's going to be a -4. Okay. Okay. Next one, same deal. Nothing exciting here. Move your decimal place 1, 2 places. So this is going to be 4.9, and then times 10 to the what? 2. Now, is that a positive 2 or a negative 2? That's a negative 2 because it is a small number. All right, easy peasy. Shortcut, count by 3s. Once again, I will often put like spaces between the zeros at every 3, so you can do that. Okay, so you go 3, 6, 9, 3, 6, 9. And then another 1 makes 10. So this would be 0.35 times 10 to the, this is a small number, so it is negative, and then we've moved our decimal place 10 places, so it is 10. We good? Let's go backwards. All right, so we see here we have a positive exponent. Therefore, our number is going to be big or small?
Big.
The number will be big. And if the number is big, do I want to move my decimal to the left or do I want to move my decimal to the right? Which will make my number big? Moving the decimal to the right. Now, I'm going to actually draw it again down here because I'm going to have to put some zeros in. So I have 3.56, and I want to make it bigger, so I'm going to move it to the right 1. And that's a 3, so we're going to move it 1, 2, 3 places. That gives us a 0 here, and that puts our decimal place right there. Now, we have to ask ourselves, do we actually want to write that decimal? So let's just write this down, 3560, and let's write it with a decimal, 3560. And my question to you is, which of those is correct? Is it A or is it B? Which one do you like? So you can choose either A, or you can choose
Wait, where is
B.
decimal point for the
for A. There isn't one. There's no decimal. Ah, do we like A or do we like B? Or I don't know yet. That's also okay. Okay, we like A. That's good because this number here has 3 sig figs and this number here has 3 sig figs, but this number here has 4 sig figs because of that decimal. So this is correct and this is not. All right? So that's the only little hitch that makes things different is those sig figs. Okay, 4.27 times 10 to the 5. Again, this is a positive exponent, so we need to make our number bigger. So we need to take that decimal and move it to the which direction? To the right. 1, 2, 3, 4, 5. Okay. So 427,000 is our answer. Do we want a decimal in there? Three sig figs. What if we put a decimal here? Then we would have 6 sig figs. So let's leave that decimal off. We don't want it there. All right. Okay, next page. Keep the sig figs the same. Ooh, here's a nice one. 3.960 has 4 sig figs. So when we move our decimal place 7 places, we end up with this number here, and we still have 4 sig figs. How could you show this number having 4 sig figs? Overbar. That's where the overbar comes in handy. Okay? The overbar indicates the last sig fig. Any questions so far? Okay. With negative exponents, if it's negative, that means that the number is small. In other words, less than 1. So we would need to move our decimal to the right or to the left? We would need to move it left. Okay, so this is -3, so we have 3.7. We'll move it 1, 2, 3 places. Okay, there's our decimal. And I'm going to put in my zeros now. I'm going to put a 0 there and a 0 there. And so my number then would be 0.0037. I would appreciate it if you would put that 0 in front of the decimal because it just looks weird if it's not there. Okay? All right. Always put a 0 in front of the decimal. It just looks better. Okay. Here's another one. 4.16 times 10 to the -5. The negative tells us that it is less than 1. And so we move our decimal to the left or right? Left. 1, 2, 3, 4, 5. 1, 2, 3, 4 decimals there. And so that would be 0.0000416. And this is the kind of number that shows you why scientific notation is nice, because that is a long number to write and it becomes hard to keep track of the zeros. We still have to watch out for our sig figs. How many sig figs in this 4.0? 2 sig figs. So 4.0 times 10 to the -3. So it's small, so we're going to have to move our decimal place 1, 2, 3 places. So this would be 0.00, and we can't just leave it at 4. It has to be 0.0040 so that we still have 2 sig figs. Is good? Okay. You guys good? Okay. All right, next page. Oh, there's some exercises here. Okay, so what I would like you to do is I would like you to, in my other block, I said to do the odd numbers, but maybe you could just do the, I don't know. Yeah, do the odd numbers, but do 7, 8, and 9 because they should all be done, okay? So +8, plus number 8. So give those a go. I'll come around and see if you guys have questions. So do all of the odd ones plus 7, 8, and 9 because they should be done together because they make more sense if you do them together. So page 113, odd numbers.
This one, I'm really not using.
What's happening here? You have 6 digits in front of the decimal.
Yes, because.
Now you can only have 1.
Oh, so this is not even right.
You kept looking at it based on the
This one's right there.
Yes.
Did that? Okay, if I move it once.
So you have like come here.
Oh, I thought you told me like how you know.
Yeah, no. So the exponent is calculated when you move the decimal. The number of sig figs is in the book. Okay, yeah. All right, and then this one. How many sig figs?
I wasn't covering, I like sensitive.
Zero. How many places do you put? Okay. Yeah, so that would be 3 0.
It's all nice.
Oh, I need it. Oh, yeah, okay. Okay, so this.
So that's pretty much-
has 3 sig
Pretty-
figs.
So how do you move?
If it has a decimal here.
I enjoy having the power.
That would, that's it. I would go. Yeah. These ones is not scientific notation. To write it in scientific notation, it would have to have just a equal. Okay, just 0.40 times 10 to the.
That's it, pretty easy. Change the mic on. What? Like a from there. You know,
There's.
you were there. Give me a trick.
Oh yeah, that's you, isn't it? That's you. That's you. You do it badly. I mean, no.
I'm not gonna believe.
Like my phone was just there, and you and Spencer in the picture. That's you, right?
Yes.
Hi.
That was all expensive.
Okay, we'll cover it, don't worry. Yeah.
I have discrimination, say that won't break the red.
Our backs. So you want to.
Watch.
No idea who that is.
I know who he is.
It's a secret. That's why I won't be. How long have you known each other?
Not that long, you called me that. Maybe at some point.
It doesn't have to be here. We can concentrate.
Okay, well, maybe at some point.
Everybody
No. No, I'm out. He's all the time. He's so sweet. Every single thing he says is so dumb. Okay, do you want to know? I'm sitting at here. I'm a girl. So I'm sure I'll decide. I'll decide. No. Yeah. But like he sat down beside them. But what do you of the class? Every day. That's a fact. They're very impressive. They were kind of good. Good morning. No. So he's this guy said, I said that my girlfriend let them. I said, hey.
Wait, again. I didn't get. I didn't get. Yeah, I know. I asked him exactly. Oh my gosh.
Then what happens? Then you go, yeah. I trust in that story. Just.
Oh, right.
Bro. I just hate when it comes up.
Yes. Okay, so for this one, I'm gonna say this here. Two. Very good. How many cities have there's lessons?
Yes, I'm ready. Bro.
Yes. So
Okay.
you need the number.
Like that, and you already do a thumbs up.
Since you only have zero, it's right now you have only two. Well, this is over here, that's just. When there's a decimal in the number, serious, but like,
I'm just checking. I think he told me the name, I don't know.
2, 3, 4, 5, 6 significant figures. No, it doesn't matter. That's okay. It's supposed to be right. As long as it's before or after those suburbs. After the suburbs. As long as this one. Yeah, so how is it? 5. How many sequences? Okay. I was speaking to tiny bit of French. Yeah, a veces. Yeah, a little bit. So for example, how would you call
Yeah, look like it was like for 100.
Mandarin kids, we're peach.
I didn't know why. But it was like the back of your head from like.
No, are you doing?
That's a judge.
Because it's very, and it might be different now, I saw this out was like 10 years ago, but it's so cheap. Because I was saying, everything that they didn't have to do by my like her
And then everybody else.
So basically.
Not even burritos.
Yeah.
I inflation that.
Okay, I'm gonna do some that was way more fun. Hi.
Girl, I
You guys
grew.
are all good?
Yeah, I grew.
No. What do you be taller?
Because he got left. You see?
What? Okay, it's fine.
I couldn't. But it won't be this hard.
I think like yeah, just like a year and a half ago.
And only one did yes. How do you do that? Or, you know, that's unique. Yeah,
Ask me anything.
But it is a question. It's not a question. I'm curious. What's that? Yeah. Don't get the joke, man.
You can't really do that. One, you can only should do that. Two.
Yes.
Yes.
No, that's been.
No, that's not the question. Yes. Already out. Nobody let everybody know how to do it.
So, your cousin.
Okay, how are we doing now?
We could all ask.
I can tell.
You need to learn out.
Why do you?
That's me. You need a lot of help.
Okay, let me see your answers. Let's just check.
I mean,
Oh,
okay, we're gonna pick up what the bottom. I know, you're like, what?
We can't be behind the other block. That would never do. So we are going to go to 1.6C on page 114. Page 114. So we have 29.4. Is that in scientific notation? No. To make it in scientific notation, we would have to move the decimal place one place to the left because we can only have one digit in front of our number. So that would become 2.94 times 10 to the something. Now this number got, did it get bigger or smaller? 29.4 to 2.94. Got smaller. And it got smaller by 1 power of 10. Yeah, because we only moved our decimal place one place. So in order for these to remain equal, this has to get bigger by 1 power of 10. So instead of being 10 to the 1, it's going to become 10 to the 2. Is good? Okay. Let's try a couple more. Key concept. Anytime you multiply two things, if they're going to be equal to each other, say, for example, we have 3 times 4 equals 12. If I make the 3 smaller, but I still want it to equal 12, I have to make the 4 bigger. So that's the principle of why if we make this one bigger by 10 to the 1, the other one has to get smaller by 10 to the 1. Okay, next example. Is this number in scientific notation? No, because we cannot have a 0. So we have to take our decimal and move it 1 to the right. So that's going to become 4.837 times 10 to the, this number now got bigger or smaller? 0.48 became 4.8. It got bigger by 10 to the 1. That means that the power of 10 has to get smaller by 10 to the 1. So instead of 10 to the 1, or sorry, instead of 10 to the 2, it now becomes 10 to the 1.
What do you say? 10 to the 2 in there?
Well,
0.4837 times 10 to the power of 2 y.
because I just made up a number. I mean, there's no good reason for that number. I could have chosen 8, whatever. All right, now if we carry on down, and I know we got 1 minute left, but let's finish this one. If I've got this number here, I have a decimal here that I can't see. I would have to move this 2 places to the left. So it would become 3.48 times 10 to the, this got smaller, and this time it got smaller by 10 to the 2. That means that this has to get bigger by 10 to the 2. What's that going to be then? Is it going to be -3 or -7? Yeah, 10 to the -3. Okay, you guys get the general idea. There are some questions for you to do on this one. Your homework is there. Catch up on 79 to 83 if you haven't, because your quiz on that is on Wednesday. Wednesday. Tomorrow you have a quiz on counting sig figs, but I think you guys are getting pretty good at that. Yeah?
Get over it.
Huh?
Get over this.
Yes,
I have another quiz for physics too.
I hear you. Sig figs, counting sig figs. You need a textbook. Oh, that's what sources are. I don't.
Take it.
Tomorrow's quiz. Let's go look. So if we go to Teams, oops, and we go to upcoming quizzes and tests. So this one, Tuesday, February 4th. Quiz on counting sig figs and circling the uncertain digits. So that would be counting sig. Why can I not flip the page? There we go. So these two. Okay, and then page 117, number 3 only. Okay, yeah, perfect.
Why did she do?
Yeah.
This job is so tiring.